Hey everybody, so in this video we're talking about coterminal and reference angles. So like other prior videos, before we jump right in, I want to explain to you what a coterminal angle is. So here we have this interactive and we have this angle in standard position and it is a 130-degree angle. Now a coterminal angle is an angle where the terminal side is in the same place as this terminal side. Okay, so here's what I mean. Here I have this point Q and it's creating this angle. I'm going to take point P and I'm going to move it to create a coterminal angle. Now, here's the thing. You cannot replicate the angle given. So I can't say, oh, a coterminal angle is 130 degrees. That's not what we're doing. But I want P to be in, I want this terminal side to be in the same place as Q. So watch what I do. Starting at 130, I'm just going to move this all the way around the circle and come right back to where I started. This is a coterminal angle. But what is that value? What would I have to do in order to find out that value? So here you'll notice what we did was we took 130 degrees and we just added 360 degrees. Okay, and then that gave us the value of the coterminal angle, which was 490 degrees. Now, how many coterminal angles could I create? So if I come right here, look, I could just add another 360, and then I've created another coterminal angle. So here, if I add another 360, I'm creating another coterminal angle. So here I have 850 degrees. 850 degrees, 490 degrees, and 130 degrees are all coterminal angles. The reason they're coterminal is because the terminal side is in the same place. Now, let's go back and start at 130. So I'm right here. Do I have to add 360 every time to create a terminal angle? Well, no. Remember, if I go clockwise, then these are negative angles. So what if I went backwards 360 degrees? Would that give me a coterminal angle? And that answer is yes. So over here by the 130, I could say, here, this is 130. And I'm going to subtract 360 degrees. And that's going to give me negative 230 degrees. Now, this could continue on and on and on. So here I could continue to go clockwise in creating more and more negative coterminal angles. But that's what a coterminal angle is. It's an angle, or it's two angles, and their terminal side lie in the same place in the quadrant plane. Now, since we know that, let's look at these examples, and they want us to list a positive and a negative coterminal angle. Now, just like before, the measure of this angle is not 40 degrees. 40 degrees, this is a reference angle. It's how far the terminal side is from the x-axis. So here I went 180 plus 40, so I know that this angle is 220 degrees. Now, I want a positive coterminal angle and I want a negative coterminal angle. So the easiest way to get the positive is just add 360. Here, I'll take this and I will add 360 to 220, and that's going to give me 580. So here I have positive 580 degrees. Now, I want a negative coterminal angle. So let's take 220 and let's subtract 360. And that should give us negative 140. Here, negative 140. Okay, and that's pretty much it. You're just identifying positive and negative coterminal angles. Now you say, why is this important? This is a very good fundamental building block. This is going to show up later in Unit 3, especially when they want your answer in degrees or radians to be bounded. So that would mean like, give me your answer give me the angle that is the answer, but the angle has to be in between 0 and 360. Well, if you're looking at it and you're like, well, my angle's 580 degrees, how do I write that out? It's like, well, what's a coterminal angle with 580 that's in between 0 and 360? And that's 220, because I could just subtract 360 to create a coterminal angle. So that's why they're useful. So let's come over here and let's look at letter B. Now, again, we have a radian. Oh, no. So remember, if you don't like radians, just make it a degree. And we can do so by multiplying by 180 over pi. Here, that's going to give us 60 degrees. So from the y-axis here, this is 60 degrees. So I know I went 270 plus 60, and that gives me 330. So here, the degree is 330. I went clockwise, so this is actually negative 330. Now, I want a positive coterminal angle. Well, that's easy. All I do is add 360 degrees, and I get positive 30. Now, I want a negative coterminal angle. So I can take negative 360, and I can subtract. Oh, excuse me, that should be 330, my mistake. So here, negative 330, and then I'm going to subtract 360. So right here, this gives me negative 690. And that is it. That is all you do. You add 360 or you subtract 360. So if I want a positive coterminal angle, I'm going to add 360 until my value is positive. If I want a negative coterminal angle, I am going to subtract until my answer is positive. Okay? Now, since all we're doing is just adding and subtracting 360, I want you to try the remaining 6 of these. So go ahead and pause this video. Try these 6 that are in your notes. I'll scroll down so you can see all of these. Go ahead and try these, and then pause the video, and I'll have my solutions on the screen. Okay, here are my solutions. So one thing we did forget to do on letter B, and that was my mistake. So one thing we did forget is we can work with degrees. That does make it easier. So we have 30 degrees and negative 690, but we can't list those as answers because here they want us to work with radians. So I should have converted 30 degrees to a radian and got pi over 6. I should have converted negative 690 to a radian by multiplying by pi over 180, and that would have given me negative 23 pi over 6. So you'll notice that I did not make that mistake in my answer key. Thank goodness. So here we should have gotten 525 and negative 195 on C. D, here are my solutions here, and here's what I did. I just took the 5 pi over 12, and I multiplied that by 180 over pi to work with a degree. That was a little bit easier. And then I added 360, subtracted 360, and then I just converted these solutions right here back to radians. Okay, now let's take a look at E through H. So here is what we should have done on E through H. All right. Now, let's take a look at reference angles. Okay, so the reference angle is the size of the smallest acute angle formed by the terminal side of the angle and the x-axis. So again, we have another interactive here. So we saw this in a prior video. Here I can create the size of any angle that I want to. So notice how right here, this is the size of the angle, and then this is my reference angle. So in quadrant 1, the measure of the angle and the reference angle is the same. But watch what happens when I go to quadrant 2. So you see how my angle here, this 118 is obtuse, but look at my reference angle. It's still 61. So watch and pay attention to that reference angle as it moves around this circle. You notice anything about the values of a reference angle? So here, what I'm noticing is that reference angles are always between 0 and 90, and they are never negative, because what a reference angle is doing is measuring a distance to the x-axis, right? So remember, distance cannot be negative. So reference angle, since it is referring to the distance from the x-axis, it is always positive. and it is always going to be acute. It will never be larger than 90 degrees. So even as I move to quadrant 3, here I have some obtuse angle, and then my reference angle is still 55. So if I'm right here and this is 235 degrees, I'm thinking, okay, how far is this terminal side from the x-axis? And you'll notice it is 55 degrees from that. And even as I move to quadrant 4, here I have 315 degrees. Okay, well, how far is this terminal side from the x-axis? And it is 45 degrees. So that is what a reference angle is. So back to this. Let's try some of these. So we have a 135 degree angle. I want to know the reference angle. So here at the reference angle, I know this is 180 degrees. So how far, if this is 135 degrees, how far do we think this terminal side is from the x-axis? And that would be 45 degrees. So here, that's going to be the value of theta. Now, if I have 210 degrees here, so this right here is 210 degrees, and this is 180 right here at the x-axis, how far is 210 from 180? And that answer is 30. All right, here we have 7 pi over 4. So that's kind of weird because you can work with a radian of 2 pi and you can say, okay, what's 2 pi minus 7 pi over 4? And you would get your answer. Or if you'd rather work with degrees, you can convert this. So I can also multiply this by 180 over pi. So this will give us 315 degrees. So here I'm thinking, okay, if this is a 315 degree angle, and we know 2 pi, that's the same thing as 360 degrees, how far is 315 from 360? And that answer is 45. So theta here is 45 degrees. And that's all you do for reference angles. Now, why are reference angles useful? Well, we can use them for a variety of things. So specifically in pre-calculus, we like to use reference angles to help us find the exact value of trig ratios. So let me show you what I mean. So here I have a circle, and you'll notice that I have all these little dots. Every dot represents 15 degrees. So here, this would be 15 degrees, that's 30 degrees, this is 45 degrees, this is 60 degrees, there's 75 degrees, here's 90 degrees, and we're going to go all the way around the circle. Now, as a sigh of relief, we're only going to do this one time. So I'm going to pull this up and show you what this looks like. All right, now I know I have the answer here. Don't worry about the answer, but if you go all the way around and label all of your dots, we're going to use this for all the other questions. So we are obviously not going to write all these numbers down on every single problem. Let's do it one time, and we'll just use that as our model. So going back to the question here, they want us to find the exact value of sine of 45 degrees. So here's what I'm going to do. I am going to have an initial side right here, and I'm going to have another terminal side, and that is going to go to the 45 degree mark. Now watch what I do. I am going to create a right triangle here. Now, I know this is 45 degrees. And they're asking us to use special right triangles. Okay, well, we know about special right triangles. We learned about those in geometry. So if you need a refresher on those, you can click on the video icon that's about to pop up right here. So we know with the 45-45 triangle, we have this rule, x, x, x root 2. Now, x can be any length. Okay, so since x can be any length, we're going to work with the easiest number we know. Let's work with the number 1. So let's change these, and we'll just say 1. So here I'm going to have this value as 1 and this value as 1. And now what they want, sine of this 45 degree angle. Well, sine we know is the opposite leg over the hypotenuse. So here, the opposite leg from the 45 degrees is going to be 1, and then the hypotenuse would be root 2. Now, you learned in Algebra 2 that you're not really supposed to leave square roots on the bottom. So we need to rationalize this. So rationalizing is the same thing as multiplying by the number 1. I'm going to multiply by root 2 over root 2. Root 2 over root 2 is 1. But what this is going to do is get that square root out of the bottom, because that's going to give me the square root of 2 over the square root of 4. And we know what the square root of 4 is. It is 2. So this answer is root 2 over 2. So we know the reference angle. The reference angle is 45. And we know the exact value. Sine of 45 is the square root of 2 over 2. And this is true. You can even test this on your calculator. If your calculator were in degree mode and you said sine of 45, your answer is going to be the square root of 2 over 2. That, or it's going to give you a really funky decimal, but the decimals are indeed the exact same. Now, let's try another one. Let's look at cosine of 225. Now, go back to your model. Look at where 225 is, and you should notice that 225 is right about here. So again, we have our initial side, which comes right here. And we have the 225 degree angle, which is right here. All right, so we have this whole thing. There's my angle. But to find the exact value of this, we are going to create a right triangle with the x-axis. So now look at what I have. I have this triangle right here, and this value is going to be the reference angle of 225 degrees. So this is the same thing we were talking about just a second ago. How far is 225 from 180? And that answer is 45 degrees. So I have another 45-45 triangle. So I know my leg lengths. They are 1, 1, and root 2. Now, you cannot forget basic algebra. I am in the coordinate plane, and I just so happen to be in quadrant 3. So guess what? Your x's and your y's have to be negative. Now, we've already answered the reference angle. The reference angle is 45 degrees. Reference angles are never negative. Okay? Now, they want the exact value. Okay, well, we know that cosine is the adjacent over the hypotenuse. So the adjacent leg of theta here is -1. And the hypotenuse is the square root of 2. Now, you may be asking, why isn't the root 2 negative? There is a reason. Do you remember Pythagorean's theorem, how you find all the legs of a right triangle? It was a squared plus b squared equals c squared. Well, any value that is squared is positive. So this was the answer to c squared, right? And c squared was the sum of two squared values. So this distance is always going to be positive, all right? The hypotenuse will never be negative in this case. Now, I'm going to have to do the same thing that I just did, and I'm going to have to rationalize. So I'm going to have to multiply by root 2 over root 2, and this is going to give me negative root 2, and we kind of already know this process. We know that's going to be the square root of 4, and that simplifies to 2. So the exact value is negative root 2 over 2. And this indeed is true. If you pulled up a calculator and your calculator was in degrees and you typed in cosine of 225, you will get negative root 2 over 2. If you don't believe me, go try it. I promise you, it does work. Okay, now let's try tangent of 135. So again, we're looking at our model that you all did over here. I know I didn't finish filling it out, but I showed you that key and you were supposed to write it out on your notes. So 135 is going to be right here. So I have this initial side of my angle that goes right here, and I have the 135, which comes right here. Okay, that's the 135 degree angle. But to find the exact value of tangent of 135, I need a reference angle. So again, I'm going to make a right triangle with the x-axis. Okay, remember, reference angles connect the terminal side to the x-axis. It will never connect to the y. So here we got 45 degrees again. Man, we're just making this nice and easy, aren't we? So we know those leg lengths are 1, 1, and root 2. Now, just like B, what happened with B? This triangle was created in quadrant 3. X's and Y's are negative. This triangle is in quadrant 2. So in quadrant 2, X's are negative, Y's are positive, because I went left and up. Now, tangent we know to be the opposite leg over the adjacent leg. So the opposite leg of theta is 1, and the adjacent leg of this 45 reference angle is negative 1. So here, my exact value is going to be negative 1. And we found the reference angle of 45 degrees. And this is true. If your calculator is in degrees and you type in tangent of 135, you will get negative 1. And that is how the calculator is finding that solution. All right, so I'm going to do one more of these. I am going to work on letter F because we have not done a problem here where we have an angle that is larger than 405 degrees. Okay, so actually, let me do a different one because y'all have not worked with a 30, 60, 90 either. Let's do D. Let's do D and then I'll do F and then I'll let you all try the rest. Okay, so we want 300 degrees. So here, that's 270. So that means this is 300. So again, I have this initial side right here with the x-axis. And then I have this terminal side right here. So this 300 degree angle goes all the way around like this. But to find the exact value of cosine of 300, I need a reference angle. And reference angles always measure the terminal side to the x-axis. Mr. Phillips, how many times are you going to say that? So many. You have no idea how many times I'm going to say that. An absurd amount. So here, this is 360. So how far is 300 from 60? 60 degrees. What? And it's always positive. Every time. Now, in that refresher video, if you clicked on it, we know the rule of a 30, 60, 90. So if this is 60, this is 90, this is 30. Across from 30 is the short leg. So that's x. Across from 60 is the long leg, x root 3. Across from the 90 degree angle is 2x. Now again, the x can represent any length because any special right triangle follows this proportion as long as it's a 30, 60, 90 or a 45, 45, 90. We want x to be the easiest number possible. So we are going to make x 1. So here, this is 1. This is root 3 because 1 times root 3 is just root 3. And this is 2. And now pay attention to where we are. This is quadrant 4. So x's are positive, y's are negative. Is the hypotenuse negative? No. This is a distance with this triangle. Distance is never negative. So here I want cosine. Cosine is the adjacent over the hypotenuse. All right. So the adjacent of 60 is 1. And the hypotenuse is 2. So here, the exact value is 1/2, and this is true. If you type in cosine of 300, you're going to get 0.5, which is 1/2. How about that? All right, back to F. So I said we were going to work on that. So with letter F, what's going on here? We got 405 degrees. We have not had one like that. How does that even fit on a circle? Mr. Phillips, how do I find that? Well, what did we just talk about earlier in this video? Like I need an angle that has the same terminal side as 405 degrees, but it needs to fit within 0 and 360. What could I do? I could subtract 360. So here, 405 subtract 360. This is going to give me 45 degrees. So guess what? If I drew a 45 degree angle, like this, it's going to have the exact same reference angle as 405 degrees. Look at math. How about that? Look at the math working. So here, 45 degrees. So we did one very similar to this in the first letter. So we know that's 1, 1, and root 2. We want sine of this, so that is the opposite over the hypotenuse. We have 1 over root 2. And we did that right up here. Yeah, it's right here. So we know this, once I rationalize, I'm going to get root 2 over 2. Okay? And that is pretty much it. Now, if you do not remember your reciprocals right here, cotangent, cosecant, and secant, okay? So cotangent is the reciprocal of tangent. So look at this. If tangent is the opposite over the adjacent, then cotangent is simply the adjacent over the opposite, okay? So this is important to know because these reciprocal identities, these are not going to go away. So even with cosecant right here, cosecant is the reciprocal of sine. So if sine is the opposite over hypotenuse, then cosecant is the hypotenuse over the opposite. Secant is the reciprocal of cosine. Cosine is the adjacent over the hypotenuse, so secant must be hypotenuse over adjacent. Okay? Now, I'm going to give you all a second. Actually, I'm going to give you quite a few seconds, and I want you to try letter E, and then I want you to try G, H, and I. So go ahead and pause the video. You need to try these. In the homework assignment, you are going to have to do this, and you will not have me just randomly pulling up answers. All right. Here is the answer to E, and then here are my solutions for G, H, and I. So go ahead and pause the video, look at my work, make sure you get the same thing I did. Now, here on these examples on number 2, we're doing the exact same thing we just did. So we are determining the exact values. All we have are radians. And since we haven't had a whole lot of practice with radians, but we have had some, you'll notice I was nice enough to list the radians on the circle. Aw, thanks, Mr. Phillips. You're welcome. Okay, now all you really need to do here is reference that degree and then try to create a reference angle and do the same thing. Now, for this, we don't need the exact value. Yeah, I'm so sorry. Yes, we do. Look at there. It helps when you read. Determine the exact value. So on these examples, they're not looking for a reference angle. They just want you to find the exact value. So again, I'm going to pause the video. I want you to try these. You're not even going to do one? No, because you know how to do this. All are you going to do? Pi thirds. Oh, look, there's pi thirds. Oh, look, 60 degrees. That's a 60-degree angle. What's my reference angle? 60 degrees. Okay, well, what's my rule? X, x root 3, and 2x. All right, try to remember where they go. If you don't know, go back to what we just did. We wrote those down. All right, so try these, and then I'm going to pull up my answer key so that you can check your work. Go ahead and take a few minutes and try the bottom as well. The bottom is just like what we just did with the examples on number 1. You're going to find the reference angle and the exact value. So the reference angle is just, remember, that distance from the terminal side to the x-axis, and then the exact value is what you get when you apply the trig ratio to the right triangle. Okay? Go ahead and pause. It is probably going to take you a few minutes to do this. That is perfectly fine. Take all the time you need and then check your solutions with mine. Okay, so here are my solutions A through F. You'll notice that I have drawn my triangle, right? I have written down the value of my reference angle. Since they're not asking for the reference angle, let's just work with degrees. Who cares, right? They're so much easier to work with. And pay attention to my sine values. This is going to be huge in this class. We are using so much information from Algebra 1 and geometry, and later in the class, Algebra 2. So we are amalgamating everything that we have learned. So you cannot forget basic rules. Okay, you can pause this video if you need more time. And here are my solutions to number 3. Now, I even wrote this down for you. Remember, if given a radian, answer should be in radians. So exact value, we didn't really have that problem because the exact value is a number. Here, they did want a reference angle, so the angle has to be expressed as a radian. All right, that's going to be it for coterminal and reference angles. If you have any questions, please reach out to me or to Miss Morgan. Or if you're not in my class and you're just watching this video, hey, leave a question in the comments. We love to hear from everybody. And I always get notifications about those, and I do respond to the comments if they are questions about the math. So let me know if you have any questions, and we'll see you all in the next video. Bye, everybody.